Hi everyone. Welcome to the new section, Atomic Operations Working with the Hardware. A lot of optimization and thread safety depends on one's understanding of the underlying hardware. This section examines compiler-specific extensions such as those in GCC. We'll also take a look at memory order. We start with the first video, GCC. In this video, we are going to take a look at how to target a specific processor architecture. Like Visual C++, GCC also comes with a set of built-in atomic functions. Since GCC is used on a considerably larger number of platforms and operating systems than VC++, this is definitely a big factor when considering portability. Before the C++11 standard, GCC used sync prefix extensions for atomics. These operations fetch a value from memory and perform the specified operation on it, returning the value that was in memory. These all use a memory barrier. These operations are similar to the first set, except they return a new value after the specified operation. And these comparison operations will write the new value if the old value matches the provided value. The Boolean variation returns true if the new value has been written. The synchronize function creates a full memory barrier. This method is actually an exchange operation, unlike what the name suggests. It updates the pointer value and returns the previous value. This uses not a full memory barrier, but an acquire barrier, meaning that it does not release the barrier. The sync lock release function releases the barrier obtained by the previous method. To adapt to the C++11 memory model, GCC added the atomic built-in methods, which also changes the API considerably. First are the generic load, store, and exchange functions. They are fairly self-explanatory. Load functions read a value in memory. Store functions store a value in memory. And exchange functions swap the existing value with a new value. Compare and exchange functions make the swapping conditional. These functions are essentially the same as in the old API, returning the result of the specific operation. And again, the same functions, updated for the new API. These return the original value, fetched before operation. Unlike the similarly named function in the old API, this function performs a real test and set operation instead of the exchange operation of the old API's function, which still requires one to release the memory barrier afterwards. The test is for some defined value. This function clears the pointer address, setting it to 0. A synchronization memory barrier between threads can be created using atomic thread fence function. And atomic signal fence creates a memory barrier between a thread and signal handlers within that same thread. This function checks whether objects of the specified size will always create lock-free atomic instructions for the current processor architecture. And this last function is essentially the same as the previous one. So that's all about GCC.